Okay, we shall start the lecture now. Today we introduce the last of the subjects, our classes, having introduced the basis, theoretical basis for decision supersystems or decision supermodels. We have seen last week, first example, the multi-criteria analysis, but is the most general model that is used for decision supersystems. Today we will discuss another class of models that are the cost-benefit analysis or accountancy models. So, as we have seen, there are several types of classifications for decision supersystems. Classification may be based on the way of representation of the data. So we have seen graphical methods or methods based on efficiency ranking, no graphics. It is typically the multi-criteria analysis systems. The former are appropriate evaluation of localization alternatives with an infinite number, or if you want, continuous of alternatives, graphical methods, while the latter, method based on efficiency ranking, are also suitable for evaluation of processes, alternative, mitigation, etc., but they are suitable for a finite number of alternatives. Of course, you understand that if you want to build a ranking, you will have to propose or to rank a discrete set of alternatives, but meaning not continuous, but a finite number of alternatives. That is different from a continuous set of alternatives for which you will employ typically graphical methods. So, we have seen that the classification of decision super methods starts from classification based on the way of representation of the data, it is graphical or listings, but also, as we have seen, multi-criteria methods, that is the typical classification based on listings. I recall you that in multi-criteria methods, you start by building evaluation matrix that is made up by confronting different project alternatives by employing different confrontation criteria. The other sets of classification is but linked to the accountancy models. It is the subject of the lectures of today. Accountancy models are methods based on essentially economic budgets. The typical is cost-benefit analysis, the one we will discuss today. That is the prototypical accountancy methods. But there are some subtle variations of this, like the budget analysis, and more specific, like the life cycle assessment. So I recall you that life cycle assessment, as well as budget analysis, as well as cost-benefit analysis, are all accountancy models that may be employed for building decision supersystems. So in the case of accountancy models, your decision supersystem will be based on some kind of evaluation that may be economic or energetic or based on mass units, and we will see some example now. The method based on budgets, as we said, is also called accounting methods, are all based on the idea that the environment originally is at balance, so that what goes in is equivalent to what comes out. Each opera or realization of humans on the territory involves a variation of incomes and outcomes that has to be assessed. So the idea is to assess what goes into the system and what goes outside, and to find some kind of criteria to decide if it is convenient or not to implement the opera. The basic mechanism is the identification of an open system and of all the enters and exits, the inputs and outputs that shall be accounted, and the budget shall be calculated. So this is the general methodology you will apply in cost-benefit analysis, as we will see today. But this methodology, it is also applied in life cycle assessment, as you will see in a couple of weeks when we will have one entire lecture on LCA. So you identify a system, you identify a kind of bordering so that you can subdivide incomes from outcomes. So you evaluate incoming resources and you evaluate the outcomes of the system, and you try to find a criteria to decide if it is convenient or not. Always accounting method, all these accounting models differ from the accounting methods and from a unit equivalent of measurements. As you will see when you will do LCA, life cycle assessment, the first step in building an LCA is that identifying a unit of measurement. Cost-benefit analysis and similar methods try to find cost effectiveness criteria or cost risk benefit and so on. Typically in cost benefit, you employ monetary units, mass balance units of mass, energy balance, so joules, watts, and so on. Ecological footprint, typically you evaluate surfaces, unit areas needed for a project to be implemented. Environmental budgets, the units vary. Generally, you employ masses, but more commonly, you will employ several or different types of accountancy methods or different type of measurements. As I told you, life cycle assessment is another prototypical accountancy methods in which the unit varies typically, generally you employ mass, not necessarily. Someone employs energies or even mixed units. The cost-benefit analysis, the one that we will look at today, is important for historical reasons. It is an economic evaluation technique of financial derivation. It is used to predict the effect of a project, a program, or an investment. It is a typically economic evaluation. Strictly financial aspects are not exhaustive, so in cost-benefit analysis is also based on social criteria that are calculated with the appropriate correction from results of the financial analysis. In cost-benefit analysis, the variables considered are therefore economic or financial, monetary, and sometimes social, that means the ability of monetizing social benefits. So we may distinguish two types of analysis: financial analysis, in which the variable type is monetary, for example, dollar, or economic analysis, in which the variable type is somehow a more elaborated indicator, classically with GDP, so gross domestic product. GDP indicator is an indicator of economic performance of the system. Typically in financial analysis, you employ market prices to evaluate or to compute the budget. while in economical analysis, you employ social prices. And for this, as we will see when we introduce the concept of ecosystem services, we need some kind of tools that allows us to convert, for example, environmental services or environmental qualities into some kind of monetary units. The first type, financial analysis, is normally employed in private analysis, while the economic analysis is that is employed in public situations. So in public analysis. So if you have to implement, for example, a cost-benefit analysis for a process of production of some goods, then you are in kind of private ambit. So you will use market prices and you will employ a monetary financial type analysis. While if you have to evaluate, for example, the suitableness or the suitability of some kind of service realization, like for example on highway or waste treatment plants and so on, these are kind of a public ambit of analysis in which you shall employ some prices derived from social analysis. The variable type are here economic, and the type of analysis, of course, is economic as well. So as we said, cost-benefit analysis is based on the identification of pros and cons of the opera in monetary terms. So costs and benefits, these are then discounted, referenced at the time of analysis to make them comparable. As we will see soon, there is a problem in comparing prices because the monetary units are not constant, but instead they vary according to the economic performance of the economic system. So you will have to be able to introduce some methodology of comparing prices belonging to different years. Then the aggregation of quantities is given by the difference between benefits and costs in order to derive the net total benefit. If the budget is positive, then the project may be approved. If the budget is negative, the project is rejected. The net total benefit, by definition, and this is the first definition you should recall, you should remember, is defined as the total social benefit minus the total social cost. So you will have to introduce a way of evaluating benefits and evaluating costs. The main steps for building a cost-benefit analysis are the following three. First one, the definition of costs and benefits. Second one, the evaluation of costs and benefits. And the last one is the comparison of costs and benefits. In the definition of costs and benefits, we may identify primary costs and benefits as well as secondary costs and benefits. Primary are values that are determined by direct effects of the project, while secondary are determined by indirect effects and hence are often difficult to identify. In this category, generally fall hardly monetizable terms, items like, for example, environmental effects. Typically, environmental effects in a cost-benefit analysis has to be considered as secondary costs or benefits. The evaluation for each year life of a project is calculated as social benefits from which it is subtracted the corresponding total social cost, obtaining, as we have defined, the net social benefit. The series of all net social benefit of each year life of a project will then be aggregated into an end value that allows to evaluate the project. We will see that we have typically three indicators of n values, but allows to evaluate the suitability of a project or not. As I have anticipated, you have to be careful because there is an intrinsic temporal inconsistency of the values. Why this? Because, as you may recall for your economic knowledge, not all prices are comparable along with different years. Given that the projects that we are discussing or we are requested to evaluate typically cover several years time span, you have to include a way of differentiating costs and benefits during the lifetime of the project. For example, if it is a time of analysis, let's say that the project starts at time 0, let's introduce for usefulness, for utility, for simplification, 1 year time step. So T1, T2, T3, T4, T5 refers to the first year, second, third, fourth, and fifth year of the project. Then the cost benefit is made by evaluating for each one of these years costs and benefits and subtracting for each year of lifespan of a project costs from benefits. But as we said, there is an inconsistency due to the fact that monetary values changes along the year according to the performance of the monetary system, of the economic system. How can we evaluate these differences? We employ the simple classical economic indicator that is called the discount rate. The discount rate is calculated, as the function here explains, the discount rate is equal to 1 divided by 1 plus R. R is the annual discount rate elevated to the number of years. This function is, of course, an exponential decreasing function, so that the discount rate fixed, the annual discount rate tends to go to 0 when the years of a project advance. We may ask ourselves, what is the discount rate? What is the annual discount rate, let's say, on the basis of which we may calculate the yearly discount rate? Sn is a yearly discount rate that is calculated on the basis of R, that is the annual discount rate. The annual discount rate is often referred to by economists as the price of money, how much it costs to lend money. Of course, this is the most general, most used indicator of economic system performances. You may ask, what is the discount rate today in Italy? So you see that discount rate has two references: where you are calculating, so in which sub-economic system you are calculating the discount rate, and when you are calculating the discount rate. For example, today in Europe, the discount rate today in Europe is fixed by the European Central Bank, and today, actually, the actual discount rate is close to 0. This is a way of pushing the economy. Keeping the discount rate close to 0 pushes the economic performance of a system by increasing inflections. So if you have to evaluate in terms of monetary costs and benefits the performance of a project, you shall employ the three indicators as I anticipated. Net actual value, where net actual value is calculated as the difference between benefits minus costs at each year of the project, normalized by the year discount rate, the yearly discount rate. So you have benefits minus cost, and you normalize this difference in terms of discount rates of the cost of money. Or you may employ a benefit cost ratio in which you divide the actualized benefits value by the actualized cost value. So for each year of a project life, you calculate the ratio between benefit and costs, and you sum for each of these two indicators, you sum it along the overall duration of the project. The third one is the internal rate of return. We may call R first, R tilde, such that the net actual value is equal to 0. The inversion points for these three indicators is net actual value positive. If the net actual value is positive, then the project is suitable and may be approved. Similarly, if the benefit cost ratio is greater than 1, this means that the benefits are larger than the cost, the project is applicable. The internal rate of return is an indication that tells us when we have a net actual value equal to 0, so where we compose the inversion point of the net actual value, and you have economic convenience if the value of the internal rate of return R first is greater than the institutional discount rate. So you may say that R first is bigger than R. I recall you that R is the discount rate. Institutional is set by central banks. In Europe is the European Central Bank. In Italy is the Italian Bank, Banca d'Italia. And these indicators are indicators that are employed by economists or economic managers in order to trim the performance of the economic system. You may say an historical example that gives you just a taste of how complicated or maybe the construction of cost-benefit analysis. This is the classical example that is always taught and took as a reference example by a paper published in 1975 by Button and Barker. The problem was that of relocating the Covent Garden market in London. So we had the problem of evaluating if it is possible or not, if it was convenient or not to relocate the Covent Garden market. Covent Garden market was one of the most important marketplaces in London. So it was an historically relevant place on which you have economic exchanges in London. The key benefits for relocating the Covent Garden market was the reduction of staffs, easiness to access, because the idea was what putting the market outside of London, lower costs of waiting, loading or unloading time, lower loading and unloading time for goods, less congestion referred to, for example, traffic, lower waste production, and the possibility of obtaining fresh products. The cost of this relocation was the acquisition of the area and the costs for the new allocation of resources and tools, so services necessary for making this market work. The analysis started by making two different assumptions for the cost of work. The first hypothesis, 10% reduction of labor and consequent reduction of tools and instruments. The second hypothesis, hypothesis B, 25% reduction of labor and so on, and consequent reduction of tools and instruments. So the two analysts have computed the different costs. For example, they started by evaluating the cost of land and the capital equipment, assumption A, capital equipment, assumption B, etc. They made really a gross evaluation in terms of monetary units. In this case, we are talking of pounds, millions of pounds. And they evaluated as a reference time 1974 or 1974-80, the interval 1974-80, or from 1980 on and so on. The discount rate, assumed the discount rate for this calculation was 8%. 8% is the yearly discount rate, institutional discount rate. Then they had to evaluate the benefits, again in millions of pounds, and a different reference time. You need the reference time in order to compute the, in order to actualize the cost, of course. So, sale of the whole site, labor cost in two assumptions, A and B, transport costs in the two assumptions, waiting costs, congestion costs, and production of waste. The result of this evaluation was that the costs were larger than benefits. In the cases of hypothesis A, we had a difference of 7.6 million pounds. In the case of hypothesis B, the difference was 6.03 billion pounds. So this is why today the common garden market is still at the place where it was 1 century ago, because the analysts evaluated it was not convenient to displace. Okay. Here, in this example, it was quite easy to compute the costs and benefits, because costs and benefits all referred to practical services or goods produced by the installation. Classically, the land costs, it is a market cost derived from the value of lands in the different places. The labor cost is a social cost that may change in different assumptions. Transport cost is in between a social cost and a market economy cost. Waiting cost and congestion costs as well. The problem arises when you are brought to evaluate costs and benefits when you have ecosystems involved in, for example, it is almost impossible or very difficult to evaluate the costs or to evaluate, for example, the benefits of replanting a forest or to evaluate the environmental costs of cutting a forest or to evaluate the environmental cost linked to nutrient discharges into ditches onto surface water systems. Why this? Because contrary to classical economic models, in which that are, if you want, summarized or described by these classical linear models. This is the models that link prices and quantity of available goods. You know that in economic terms, if the demand is larger than supply, then the prices of a good tend to grow. On the contrary, if the supply is smaller than the demand, the prices of a good tends to grow. So the equilibrium point of these two models, the supply-demand model, that is a very complex linear model employed in economy. This is the most of the complexity of an economic model that may be employed. The point of equilibrium of this model, of course, is the point at which supply is equal to demand. So point B in this graph. This is what happens when you employ this economic model onto market systems in which you have a supply that is limited, a demand that is limited, so that you can describe these two relationships by linear rows. But something very strange happens, or something very difficult, if you want, happens when you try to apply this kind of model onto natural goods, natural systems. The problem is that when you deal with natural system, there is no such equilibrium point in which the supply is equal to the demand, simply because the supply-demand lines are not crossing each other. Instead, most of the time it happens, for example, that the supply lines is vertical, so that you do not have a crossing point on which you have an equilibrium. What does this mean to put a vertical line in the supply or marginal cost of supply? This means that if you are losing a product, or if you are, for example, destroying a resource that cannot be easily produced, then the space in which your cost supply or supply-demand model is applied is not anymore a linear space. So that, for example, you have a vertical price line and you have an horizontal demand line, so that the only equilibrium point is at the zero. Of course, these are the two extremal situations. In a real system, what often happens is that you have, for example, a line that is not so one-to-one, and here you have a line that is not so one-to-one again, so that you see that the intersection point here in this second example falls very high in the price space. This means that the equilibrium, when the resources are not easily to be produced, is found in a place in which the price is very, very high. How can we evaluate this when we refer to natural systems or to ecological systems? Okay. We have to wait until year 1997, in which there was a, how can you say, a turning point, a cornerstone paper published by Bob Costanza and several other authors. It's a paper with almost 30 to 40 authors that was published in Nature in 1997, and the title of the paper was The Value of the World's Ecosystem Services and Natural Capital. What they have tried to do in this paper in 1997, as the title suggests, Costanza and collaborators have tried to evaluate the total value of the services provided by nature. This paper is very important because it gave rise to a new branch of economy, what is now called environmental economics, in which an effort is made in order to give a monetary value to environmental services. The paper, or this reasoning, is based to the introduction of the concept of ecosystem services by realizing that ecosystems provide services, for example, cleaning water, producing clean air, oxygen, or for example, producing suitable landscape or suitable habitats for endangered species and so on. These are all ecosystem services that are produced by nature, by ecosystem, on the basis of its natural capital. So the point is reduced to that of evaluating the natural capital. You may imagine that this is quite complex, quite a complex evaluation type, but in the original paper of 1997 of Costanza, we had the first evaluation in US dollars. The value of natural capital was in the range between 60 to 54 trillion of dollars per year. And the global gross national product total is around $18 trillion per year. So by the estimation of Bob Costanza and co-authors of 1997, it was estimated that the value of the services produced by nature is worth around 18 trillion US dollars per year. That is, in economic scales, enormous. If you think that the gross domestic products of large nations is around billions per year, Here we are talking about one or more order magnitude larger quantities, trillion per year. On the basis, of the work of Costanza, it was possible to plot this kind of maps in which, in terms of ecosystem services, you can differentiate the values of different areas of the planet. Of course, you may recognize here that Amazon forest spots in red, of course, because it is the so-called pulmon of the Earth, in which all the oxygen, a significant part of the oxygen of our atmosphere is produced, and this happens in all the equatorial areas. We have some other relevant spots, for example, this is in North Siberia, because you have a significant production of oil, for example, or natural resources in these areas. And we see, of course, that the places in which natural production is lower are those in which you have desertic situation, like, for example, Northern Africa. This way of evaluating the effects of human activities on ecosystems is very relevant, is new. When the paper of Bob Costanza sorted in 1997, I was a little bit unhappy, because my first consideration was, oh, it is disgusting to put an economic label on things such as a nice landscape, or a nice coastal area, or a nice bird, or an interesting timber production, and so on. But little by little, I have understood that this way of presenting things is very useful for policymakers, because policymakers, they like to talk dollars and euros, because dollars and euros are very easy to understand. So to policymaker, instead of saying, oh, you're going to lose hectares of primary rainforest, you should tell them, oh, you're going to lose billions of dollars. They will raise their ears much more, so they will be much more attentive. So this is the great advantage of employing ecosystem services evaluation. And we will see an example of a project that we have carried in the Lagoon of Venice, in which the project Vimine, in which we proposed a different innovative way of managing salt marshes areas, that are areas of a very important ecological value, but are not enough protected. And why? If you make an economic evaluation in terms of ecosystem services provided by salt marshes, it becomes much more easy to justify or to explain why salt marshes in general are very important to be protected. Because if you make an evaluation in monetary terms of what you lose when you lose salt marshes areas, it becomes immediately clear to policymakers that these are areas or ecosystems that need to be protected. Okay, we shall go we shall finish the lecture of today by giving a look to our accounting methodologies. Classically, environmental budgets was, if you want, the ancestor of ecosystem services evaluation. Environmental budgets are voluntary disclosure documents that describe the main relations between the company, or the opera, and the environment. In particular, these budgets are framed into different frameworks, like environmental management, environmental aspects that measure the extent of impact factors generated by enterprise, environmental performance of an enterprise. These are all indicators that you can calculate on the basis of environmental budgets and gives you tools for evaluating the environmental performance of environmental efficiency of a given enterprise, potential effects on the environment potentially produced by the company. And we can identify essentially two types: environmental reports for one side, refers to individual installation or production establishment. It is a local evaluation. And you may have instead corporate environmental reports. So these corporate environmental reports are typical for multinationals enterprises in which you have several sites of productions. So multinational enterprises with several sites of production, they should carry several environmental reports for the different sites and make a global or multi-sites company, or if you want, corporate environmental report. Alessandro Manzardo next week will start to introduce these kind of tools, voluntary tools for the evaluation of environmental performance. There are guidelines set by various international organizations, such, for example, the European Chemical Industry Council, or the Public Environmental Reporting Initiative, or the ICLEI, that is the Local Government Association. In Italy, the most relevant one that draft out guidelines for performing environmental evaluations are the Fondazione Enrico Mattei, FEM, and the CLEAR project, City and Local Environmental Accounting and Reporting. The environmental balance is achieved through the construction of quantitative tables that describe the physical and monetary environmental management data, and which initially recorded in accounts are subsequently reworked in order to assess the efficiency of sustainable orientation, the efficiency or the sustainable orientation of the company. So these are special flavors of cost-benefit analysis in which you try to specifically evaluate the environmental performance and environmental management of some companies. The environmental reports are structured in the following forms of accounting. So you have resources used. Typically, these are the chapters of an environmental resource report. Resource used, waste produced or waste products, atmospheric emissions, pollution of surface water and groundwater, pollution of soil and subsoil, production of annoying noise, environmental expenditure in general, summary of the data under full accounting. So as you will see when we will be describing life cycle assessment, these are essentially the chapter by which you build an LCA analysis. There are other type of environmental budgets that are divided in terms of production or different documents, what we may call environmental reporting. You have periodic environmental budget plans, accounting, but are maybe continuous or not. So for yearly accounting or environmental budgets itself. Typically, an example is that of energetic balance, which is territorial balance. The energy balance is based on the three main issues: actual energy demand and future demand estimates, energy supply, so the offer, and environmental externalities related to energy use and production through the construction of emissions budgets. So what I refer to externalities typically are the effects or the role of the surrounding environment in terms of providing resources and providing waste disposal services. The analysis of energy demands permits quantification of the energy flows and its historical reconstruction. It allows to examine the intersectoral distribution. It may be disaggregated at a regional level to analyze the temporal evolution and to reconstruct the theoretical energy requirements of each sector involved in the performance of the company. Then there is another important, for historical reasons at least, indicator of environmental performance that is called the ecological footprint, or if you want, the human footprint. It was developed in the 1890s in Canada by William Reeves and Matthews Wagenengel. It's a method that combines the calculation of a budget with the concept of a carrying capacity of a given territory. You may have already introduced the concept of carrying capacity. Carrying capacity is the ability of a portion of the territory to sustain an activity in terms of resource production and in terms of waste disposal. Instead of asking how many people can be self-sustained, we may ask how much land each person requires to be supported. You understand, this changes completely the perspective from assuming that there is an unlimited quantity of resources and an unlimited capacity of waste disposal. We change the perspective by saying that we are asking instead how much each person needs in terms of production of resources and waste disposal. It is an environmental indicator, ecological footprint, that describes the pressures coming from human activities on the basis of the total area of terrestrial and aquatic ecosystem. So it is a measure of the amount of territory that is needed to produce in a sustainable way all the resources that man consumes and to absorb all wastes. So the ecological footprint, as expressed in the 80s and 90s, it is a way of combining cost benefits with ecosystem services evaluation. So by calculating the ecological footprint, you are including cost and benefits evaluations in terms of ecosystem services. But okay, nowadays we know this because nowadays we have invented the concept of ecosystem services, and we have invented the decision support system that is called cost benefit analysis. But in the 80s and 90s, we did not have already developed all these tools and all these concepts. So this is why it is important to know where this concept comes from. The Ecological footprint is easily calculated. The calculation is done by transforming consumption per capita in units of equivalent area or hectare of land. So it is a very easy formulation in which you have the product of three quantities, the number of individuals, so population. A is a measure of the average resource consumption per person, and T is an index of environmental harmfulness of the technologies providing consumer goods. So it's a way of measuring the quantity of waste production produced in general. Classically, the ecological footprint uses 5 categories of consumption. Nowadays, we call these pressures. First one is food production, housing providing, transport providing, consumer goods, and services in general. Then consider 7 environmental components. Nowadays, you are expert and you know very well what we mean by environmental components. There are somehow state indicators. Classically, in the ecological footprint, we have farmland, pastures land, managed forests, natural forests, sea area, so and coastal zones, urbanized land, and use of non-renewable resources, like it is, for example, gas or oil. The ecological footprint for the analysis of consumption, for example, you may employ meat, dairy foods, dairy products, fruits, vegetables, legumes, wheat, tobacco, coffee, wood products. So in the classical ecological footprint, we had more than 50 biotic resources, but we'll consider. The consumption were calculated by adding to the domestic production the imports and subtracting the exports. For the energy balance, it is taken into account the energy locally generated but incorporated in more than 100 categories of marketed products. The final part of the calculation summarizes the ecological footprint in the categories considered above and provide the total per capita evaluation. Okay, for a matter of completeness, we have to cite also the terrestrial ecological balance. That is, if you want, one of the ancestors of the ecological footprint. It was based on the idea that any urban area can be described as an ecosystem that consumes non-renewable resources and generates waste and emissions, consumes energy, and is not self-sufficient. The territorial ecological balance is a document that analyzes and reports for a given territory, so a given portion of land, the data about the state of environment in terms of air, water, soil, subsoil knowledge, biodiversity, landscape, and so on, as well as the pressure factors, population, transport, energy, waste, industrial, commercial, or agriculture and tourism. Okay, we stop here for today. I recall you that next Thursday we will discuss the subject for the group works. I recall you that the group work, so the production of a report and the presentation of the report in the class, is one of the elements that make up your final grade for the exam. So what I'm expecting on Friday, I will present some subjects, some titles. I will propose some titles for work groups, and I would like you to choose the titles and to group in work groups. Don't worry, because I will give you an opportunity on Moodle to select work groups on the basis of the first selection that we will make next Thursday. So next Thursday, I will ask you to send me an email telling me how I would like to work on this subject. So I will make up a group with the subject name, and each person in the class in Moodle may join one of these groups. And so you may try to work together in groups and to produce the report and to present your work group activity. As I told you, this activity gives you up to 20 points over 30. So you can get the exam only by doing a nice or a good work group job. Then if you want to get more than 20 points, you are asked to come for an oral examination that I will be carrying during the end of January, beginning of February. If you have any question, I'm here for some time now, or otherwise I close the classroom and we shall meet on next Thursday.